Okay, in the second problem we have an initial upward velocity 15 meters per second, a downward acceleration of 10 meters per second squared. So after 1 second, what's the velocity going to be? Again, I got good answers fairly quickly. People say, well, 5 meters per second, indicating that a lot of people understand what this 10 meter per second squared tells you, that the velocity changes by 10 meters per second downward every second. Now, of course, if you have an upward velocity of 15 meters per second and it changes downward by 10, that's going to leave you 5. So velocity will change by this downward, so that the velocity at 1 second, using function notation, v of 1 second, is going to be 15 meters per second minus 10 meters per second, 5 meters per second, which means 5 meters per second upward. Okay? Now, so during the first second, how far do you travel? Well, what do we know? We can identify that we have the initial velocity and the final velocity during that first second. And we also know how much time elapses during the first second, which is 1 second. So we multiply the average velocity, the average of the initial and the final, which is 10 meters per second, by the 1 second, and we find that the object moves 10 meters. So after 1 second, it's going to be 10 meters higher than it was at the start. Okay, well, how do we apply the same logic to 2 seconds? Again, a lot of people said, well, it's going to be moving at negative 5 meters per second. Well, that makes perfect sense, and it's right. You're going to be moving upward at 5 meters per second, and you're going to change by 10 meters per second in the downward direction, which is going to take you from plus 5 to minus 5. Then, to determine where the object is going to be at that point, we average the initial velocity. At t equals 0, we're moving upward at 15 meters per second. After 2 seconds, we're moving downward at 5, so that would be, we're going to average 15 and negative 5 for that 2 second interval. And that average is 5 meters per second. So that the displacement is going to be 2 meters per second times 2 seconds, which is 10 meters, the same as it was here. Now, what's that mean? Well, that means that from the start to the end of the first second, we go up to 10 meters. After another second, we're still at 10 meters, but we didn't just stay there. We went up and we came down, because now we're moving at negative 5 meters per second, as opposed to the plus 5 meters per second we had after 1 second. So that means we had to go up and come back down, but now we're down at the same point that we were after 1 second. Now, the question, of course, asks you to do it for the 3 seconds interval. And you can work that out and see what your conclusions are. If you understand these two, you're going to be able to do that.